So in this video we are going to see about the linked list insertion. So I already said it contains the 4 cases, and the previous video we saw the inserting the new node at the beginning, and here we are going to see inserting the new node at the end. Okay, so for example, consider this is a linked list we have taken. So here we need to add the new node at the end of the list with the data 5. Okay, so where we have to add the new node, so we have to add the new node here. Okay, we need to add the new node here. So here we have to add the new node, and it contains the data as a 9. So what will happen? So this node data part will be the null, and here it contains the address of this node, so we have to give the link. So how we will find the last node? So what we will do means we will check one condition. So what condition we will check here means PTR tends to I will write here PTR tends to next, it is not equal to null. We will check this condition. So when we are checking this condition, if the node is available means it will be not a null. So till getting that particular node, what we will do, we will search that particular node, and what we will do, we will insert the new node at the end. Okay, so we will see the code for this, and with the code I will explain how the process will be done here. So here we are going to insert the new node at the end. Okay, so first what we are doing, we are declaring two pointer variables, that is char ptr and char new node. Okay, then next we are using the variable num, so this is for the data, and by using the printf statement, what we are doing, enter the data. Then by using the scanf statement, what we are doing, we are going to get the value of the num from the user. So as per this example, what we have to do, we have to add the 9 as a data. Then next, by using the malloc function, what we are doing, we are creating the new node. So by using the malloc function, we are allocating the memory space for the new node. Okay, so after allocating the memory space for the new node, what we are doing, we are going to allocate the value for the node in the data part. So that is new node tends to data is equal to num. So what is our num value? It is 9. So we have to assign the value here. Okay, then what we have to do, new node tends to next is null. We have to in address part, we have to assign the value as a null. So why we are assigning the value as a null means, here we are inserting the new node at the end. So the address part will be the null. Then next what we are doing, PTR is equal to start. So this is our start node, and this will be our PTR. We have assigned PTR is equal to start. Okay, then next we have to execute this while loop. In this while loop, we are checking the condition PTR tends to next is not equal to null. So by using this loop only, what we are going to find the last node. So till this condition getting false, what we have to do, we have to execute the loop. So inside the loop, first it is given PTR is equal to, if this condition is for true means, okay, this condition is true means the PTR node will be changed here. So PTR is equal to PTR tends to next, then PTR tends to next is equal to new node. So here what will do means, so this is the loop. So this is the loop. So whenever this condition is true, this loop will be executed. So first you will see. So this is the PTR node, and we are checking it is not equal to null. Yes, it is not equal to null. So this condition is true. So what we have to do, we have to change the pointer. So now the pointer is here. Then again we are checking PTR is not equal to, PTR tends to next is not equal to null. Yes, it is not equal to null because here there is a node. So we have to execute this line, that is PTR is equal to PTR tends to next. So now this is the PTR. Then again we are checking the condition, PTR tends to next is not equal to null. Yes, it is not equal to null. So here there is a node. So we have to execute this line. So now this is a PTR. Right. Then next again we are checking the condition. So there is a node. So this is a PTR. Then next we are checking this condition. There is a node, so this is a PTR. Then next we are checking the condition, there is a node, this is a PTR. And now we are checking the condition, PTR tends to next, so it is a null. So what happened? The condition becomes false. So it will come out of the loop and it will execute this statement, PTR tends to next is equal to new node. So here what will happen? The address of this new node will be assigned here. Okay, so this part contains the address of new node. Okay, so now what we have done? We have inserted the new node at the end. Then we will see the algorithm for this. So this is the code which we saw in the previous slide, and this is the algorithm. So here first we are checking, so already I told we have to check the overflow condition here. So we are checking avail is equal to null. If this condition is true, means what will happen? It will write overflow and it will go to the step 6, step 10 and it will exit. And if this condition is false, means it will go to the step 2. So first what we are doing, we are creating the new node. So new node is equal to avail. The next what we are doing, avail is equal to avail tends to next. We are allocating the memory space here. The next what we are doing, we are allocating the value for that particular new node, that is new node tends to data is equal to value. Then next we are allocating the address part as a null because it is the last node. After that node there is no node, so the address part will be null. So we are assigning new node tends to next is equal to null. Then what we are doing, we are assigning the starting node as a PTR here. Okay, then we are checking the condition, PTR tends to next is not equal to null. So till this condition getting false, what will happen? This loop will be executed. Once this condition getting false, means we have reached the last node. Okay, we have reached the last node, and what we will do, we will assign PTR tends to next is equal to new node. So the address of the last node, okay, the address part of the last node contains the address of the new node. Okay, so this is about inserting the new node at the end.